Hello everyone and welcome to another math tutorial video. This time we'll be looking at dividing radical expressions, which is on IXL L8. So the directions just tell us to simplify, and in my opinion this is a little bit easier than multiplying, but to each his own, I guess. You may disagree. So here we have the square root of 50 over 14. So all of that is under the radical. So there are several different ways you can do it, but the thing that I think is easiest is actually to simplify before you start anything else. So before you even mess with the radicals, because I know that 50 over 14, 50 and 14 both will divide by a common factor. So if I divide these by a common factor, which will be 2, they're both even numbers, then after that I'm going to end up with the square root of 25 over the square root of 7. Now you may wonder why I split it up. Well, if I have the square root of the whole thing, that means everything inside that square root is all being done to the square root, so I can't actually break it up like that. So the square root of 25, that should be a red flag to me that automatically is going to be a whole number, which is 5. It's a perfect square. So we have 5 over the square root of 7. So now, one of the math no-nos, math no-nos like dividing by 0 and, stuff like that. Well, we can't have a radical in the bottom. So the way to fix that is to do what we call as rationalize the denominator. So to rationalize the denominator, I can multiply by the same thing on the top and bottom, and what I want to multiply by is the square root of 7 and the square root of 7. Okay, now the reason this works is, think about it this way. The square root of 7 times the square root of 7 is the square root of 49. Well, the square root of 49 is 7. So on the next step, that's why that works. So on the top, I'm going to have 5 on the square root of 7. And then on the bottom, I'm going to have square root of 49. Now, I may skip this step in the future, but to finish this off, I'm going to have 5 on the square root of 7. And then on the bottom, square root of 49 is 7. And none of that will simplify anymore because 5 and 7 don't have any common factor. So I would just leave it as 5 on the square root of 7 over 7. Okay, so let's try another one. So on this one, we got the square root of 4 over 50. So just like in the last one, I'm going to divide by a common factor. So I know that both of these will divide by 2. So when I do that, I'm going to end up with the square root of 2 over the square root of 25. Okay, so can't really do anything with the square root of 2. So I'm just going to leave it as the square root of 2. And the square root of 25 is 5. So that's done. See how quick that was? Wasn't bad at all, was it? Okay, so let's try another one. So on this one, let's do the square root of 10 45ths. Okay, so alright, this one, well, once again, I can simplify. 10 and 45, they both divide by a common factor of 5. So divide by 5, divide by 5. So I'm going to end up with the square root of 2 over the square root of 9. 45 divided by 5 is 9. So the square root of 9, well, another perfect square. So I have 3 on the bottom, and I have square root of 2 on the top. So pretty similar. Let's do another one. So on this one we have We have some big numbers here. So let's do 343 over 245. Okay, now when you look at this one, you may not readily notice that they have any common factors. So, for example, 343, if I add all those up, they won't divide by 9. So it also won't divide by 3, using my divisibility rules. 245 will divide by 5. One thing I should notice, though, if I know my perfect cubes, I know that 343 is a multiple of 7. So that'll divide by 7. 245, would it divide by 7? Well, what I want to do is divide it by the biggest number I can, and I think both of these end up dividing by 49. Now, yeah, if I divide 343 by 7, I get 49. So the perfect square that goes in that, will divide these both by 49. There are multiple ways that you can do this one, but the top will divide by 49, and I believe also the bottom will. Yep, it does. So when I divide that by 49, and I mean, I could divide them both by 7, and I would have larger numbers, but I would need to break it down more. But the more you can simplify it, the better. So basically, we're going to have the square root of 7. I'm not keeping this very consistent, am I? Over the square root of 5. Okay. So on this one, well, I need to rationalize the denominator. And the way I would do that is multiply by square root of 5 on the top and bottom. That will take care of that square root of 5, because we cannot have a radical on the bottom. Okay, so when I do that, I'm going to get the square root of 7 times 5 is 35 over, well, I'm going to have the square root of 25. Well, the square root of 25, that is 5. So my final answer will be square root of 35 over 5. And that's really all I can do there. All right, so let's try one that has variables in it. Okay, so we have the square root. Notice all these are square roots. 15g to the 8th. Tell you what, instead of g, let's use h. So 15h to the 8th over 4h to the 3rd. All right, so first things first, 15 and 4, can't simplify those. So can't really do anything there. But I can, since I'm dividing, I can subtract the exponents. So 8 minus 3 gives me 5. So I can do that. So this is going to end up being, hold on, I'm trying to figure out how I want to show this. So this will be the square root of 15h. So in my, let's extend this over. Okay, so I'm going to have 15h, and then let's show how I'm subtracting exponents. So it'll be 8 minus 3. It's supposed to be an 8, okay? And on the bottom, I'm going to have the square root of 4. And that's really all I got down there, because the h's I moved all to the top. Okay, so as I finish this off, I'm going to have the square root of 15h to the 5th And then all over, well, the square root of 4 is 2. Now, just like we did in a prior lesson, well, if I have the square root of 15h to the 5th, I actually can simplify that. So let's do that. So I need to simplify this. So I'm going to go 5, and since I'm taking the square root, I'm going to actually divide that by 2. So 2 goes into 5 2 times. 2 times 2 is 4. Subtract that, I get 1. So I'm going to have 2, remainder 1. So that means that, so I'm going to have equals, okay, so outside I'm going to have h to the second because 2 of those came out. So I'm going to have h to the second. And then, hold on, let's write it down here where we have more room. So I'm going to have h to the second. And then still inside the radical, I have 15 because that's not a perfect square, and it doesn't have a perfect square inside it. And then 1h was left because I had a remainder of 1. And then over 2. Okay, so one more example. Let's do another one with variables. Okay, so here we got the square root of 25 over 9m squared. Let's do it at 9m to the third and make it a little bit harder. Okay, so on this one, well, I can see right at the start that 25 is a perfect square, and so is 9. 25 and 9 don't have any common factors, so I can't really simplify it that way. However, I know that the square root of 25 is 5. The square root of 9 is 3. Okay, but I got to leave the square root of m cubed inside because I haven't really dealt with that yet. Okay, so to continue this, well, we can rationalize the denominator just like we could if I had a number. So basically, I want to get that m to the third to come away. So one thing I could do first would be I could take out, well, there's multiple ways I could do this actually. I could just multiply the top and bottom by m to the third, so that might be the easiest thing to do. But there's another way I could do it. I could actually just take some of those m's out right off the start, but let's just do it this way. So we're going to multiply by the square root of m cubed, and we're going to do that on the top and the bottom. Okay, so when I do that, I'm going to end up with, so on the top, I'm going to have 5 times the square root of m cubed over 3, well, times the square root of, well, I have the same base, so I'm going to add my exponents. So that's going to be square root of m to the 6th. Okay, so on the bottom, the square root of m to the 6th, I'm dividing my exponents. So I'm going to have 6 divided by 2. Let me show this here. So on the bottom, so I'm going to do 6 divided by 2. I know that yellow is not the easiest to see. So I'm going to get 3. And on the top, take care of this one. We're going to end up doing 3 divided by 2. So it goes in once. 2 times 1 is 2. Subtract. So I get 1 remainder 1. Okay, so how are we going to write that? So on the top we have 5, and then it had m to the first that came out, but still inside the square root I had a remainder of 1, so I'm going to have m inside. On the bottom, I have 3. And as you see in yellow there, what I did, 6 divided by 2 is 3. So I'm going to have 6m, or 3m to the third. Now, we're not done, because last thing, since I have m cubed on the bottom and m to the first on top, the last thing I can do is I can subtract, or I'm dividing, so I'm going to subtract my exponents. So we're going to have, so our last thing, let's handle this. Let's show an orange, so we can actually deal with those. So when I have 5 on the square root of m, remember my biggest one's on the bottom, so that means all of our action's going to stay on the bottom. So I have 3, and then go to m, and then in orange here I'm showing my final thing I'm doing, which is the exponent of 3 minus 1. And I dropped my thing. So we're going to have on the top just 5 on the square root of m. And on the bottom we're going to have 3m to the second. So I hope that you found this video helpful. A little bit tough, but not really too bad, is it? And I know y'all got this. Hope y'all have a great day. Let me know if you have any questions or concerns.